7. This time we compare natural log function belongs to little o of n to the dth power function, but what is that d number? D we only require d is a positive constant, d greater than 0. That's the only condition we have. Now, let us apply the L'Hopital's law another time. Yeah. Natural log of x over x to the dth power function. Yeah. Indeterminate form. So we can apply the derivatives immediately. Natural log derivative 1 over x. Okay? Yeah. Power rule d times x to the d minus 1 power. Yeah. After simplification, yeah, do simplification. Yeah. So we get 1 over d times x to the dth power. But this time, this new fraction is not indeterminate form. 1 determinate, right? 1. So you cannot apply L'Hopital's rule another time. All right. So let us just consider when x goes to infinity. D positive number. When x goes to infinity, even d is here. D is positive. We know x to the d must be infinity. 1 over infinity, 0. So then conclusion, little o. Little o. Yeah. So this example is very important. Why very important? Why very important? Here, let me show you the meaning. Natural log function, power function. When we compare log function and a power function, our power function, the d number, we only require it is positive. So that means d could be a very small number. Still positive, right? Think about it. Yeah. So let me write something here. Yeah, let me change the color. All right. Think about, how about d equals, yeah, here, just one special example, d equals 0.000001. Many zeros. How about that? That is a very small positive number. You can see 1 millionth, right? D equals 1 millionth. You take the root function, 1 millionth root. 1 millionth root. How small it is. Okay? But it is still increases much faster than natural log function. Okay? Even you take 1 millionth root, you get, because when you consider the limit, still the limit equals 0. Okay? But if usually students, based on their intuition, I compare these two functions. I ask them which one increases faster. Okay? Yeah, I give many similar questions in the homework assignment. When they see 1 millionth, 0 point so many zero, usually they tell me close to 50%. Close to 50%, they tell me natural log of n increases faster. Natural log of n increases faster. 50% of the chance. Answer is n to the d increases faster. Eventually, think about, we only look at n very large, all right? We don't worry about where n is relatively small. We only look at very large. And one student even argued in this way. It looks pretty convincing, but it's wrong. One student told me he tried to use some online calculator. Do calculation, because your little app calculator, you cannot handle that big calculation, right? N to the 0 point that power. I don't know if you can handle. So that student used the online calculator, very powerful calculator, like Wolfram Alpha, okay? Wolfram Alpha. Yeah, I use that a lot. Yeah. So they told me when they plug in n numbers, even n numbers really large, that number very, very small, okay? So they told me log of n is faster. No. Even you plug in numbers using some calculator, the number, the size of the number you can handle very limited, right? Very limited. Yeah. But here we talk about theoretical result. We talk about theoretical result. There is no limitation on the size of the number. No limitation. The number you plug in, you have a limitation because you cannot go too large. You have limitation. But here, our n, no limitation. So that's why our formula, our computation tells us which one is faster. Not based on your experiments, right? Your experiments, you have limitation. So that's why it may not be correct, right? Yeah. So we, based on the math calculation, all right? Yeah. So that's some comments for this question.